My name's Dylan and I'm with Halogen Systems, and today I'm going to show you how to do a 2-point pH buffer calibration. The things that you're going to need for this calibration and process is a pH 7 buffer. You can get these from any chemical supplier. You want to have made it that day or very recently, not have left it out in the sunlight or anything. That way we know that it is actually pH 7. You're going to want a tap water rinse solution. This can just be filtered tap water out of the sink. It can also just be bottled water, or ideally you can use deionized water. But it's going to be whatever you have available to you. Really all we're going to use that for is rinsing between pH buffers, just to make sure that we're not contaminating the next buffer that we'll be doing the calibration in. And then the last buffer you're going to need is a pH 10 buffer. pH 10 is a lot less stable than pH 7, so this one you definitely want to have made that day, or just open that solution packet that day as well. So, as you can see, my sensor is already running and adequately primed just in the tap water, so we know everything's working correctly. So the first thing we're going to do is go ahead and move into our pH 7 buffer. We're going to pull it out of the tap water. You're going to want to get rid of as much water as you can. That way we're not degrading our pH 7 solution here. And then we're going to move the sensor, keeping note of where the ejection port is, into our buffer here. Now a lot of the times the sensor is not going to prime itself, and you might have to give it a little swirl to re-establish flow. Before we do any sort of calibration or anything, you're going to want to check and make sure that you can see visually that we have pH buffer flowing out of our ejection port. As you can see there, I now know that my sensor is adequately primed, and I'm going to go ahead and just leave it here for about 3 minutes to let the sensor equilibrate to the new pH 7 solution. While it's equilibrating, we can come over here to the display, and as you can see here, it's reading pH 8.31, which means it hasn't updated since I put it into that pH 7. And this is why we want to give it a couple minutes. It takes a few cycles just to make sure that we're getting adequate and accurate measurements. The other place that we can watch to see what our pH is doing is we can come here to the pH sensor A to D and see what this value is. And we really want this value to be 0 millivolts plus or minus 40. If it's outside of that range, we're not going to be able to initiate a calibration. Ideally, this value should drop down to pretty close to 0. And I'm going to wait and watch this value for about 3 cycles. That way I know when it's no longer changing. So we're going to open back up, negative 31.6. And I'm going to wait until I see that value change again, or if it changed. If it doesn't change across 2 to 3 minutes, then we know that we're pretty stable. As you can see, our pH is starting to drop. We'll go ahead and take a look and see what our millivolt value is, negative 33.6. This is also a good time to double check that we don't have any averaging turned on. So if we go to Menu, Configuration, and then all the way down to the bottom here we have averaging options. We're just going to want to double check and make sure that these values are both 1. Otherwise we're going to see that pH value dropping really slowly if we have like a 20 cycle averaging going. So I'm going to give this one more cycle. So I've seen negative 31.6 and negative 33.6. I'm going to give it one more cycle and see if we get much change. I'm looking for changes less than about 2 millivolts between cycles before I'm going to initiate a calibration. And I just saw it change again. And we're at negative 33.6 still. So I'm going to say that this is pretty stable, and we're going to go ahead and do our pH calibration. To do a 2-point buffer calibration, we need to select the long menu by holding select and right arrow. We'll get our confirmation that it's selected, the little L in the corner. We're going to go to Menu, Calibration, pH, and then we're going to go to 2-point buffer calibration. The first one that we're going to complete is the pH 7 buffer calibration. We're going to hit select. It's going to tell you to place it in the buffer. We're already in that buffer and we know that we're stable. So we're going to go ahead and hit calibrate. And it's going to give us a stabilizing. This could take up to a minute, maybe a little bit longer. Once it's stabilized, it'll give you a success, and it's going to ask if you want to move to 10 buffer cal. In our case, we're going to go ahead and say no, because I want to rinse the sensor, and I want to do the same thing we did with the 7 buffer to confirm that we are stable prior to completing that 10 buffer cal. So I'm going to hit no. That's going to put us back to here. Don't be alarmed that you see a 7.58 here. It usually takes about a cycle for the calibration to update. So we're going to sit here maybe for another minute, and then we're going to confirm that our pH goes to 7. The other place that we can confirm that our pH 0 has changed is by looking at the pH Z here, and it's 34.1. What that's telling us is that we did our 7 buffer calibration when our pH sensor was reading negative 34.1 millivolts. It's just a simple offset where it's going to add 34.1 millivolts to align our pH offset calibration. So we're continuing to monitor our pH millivolts in 7 buffer, and our pH millivolts are still close to where we did our calibration. So we're going to go ahead and double check on our reported pH and see that, yep, it is just about 7. If it's 7 plus or minus 0.05, that's usually acceptable to me because we might be applying a temperature compensation. All of our pH calibrations are expected to be done at 25 degrees Celsius. So if we have a little bit of a temperature difference, you might see a slight difference in the reported pH because we're applying our temperature compensation. So now that I know that the 7 pH calibration was good, I'm going to go ahead and rinse the sensor. We're going to pull it up out of the 7 buffer, get as much of that 7 buffer out of there as you can, moving the sensor around. And then we're going to put it into our rinse solution. Now we're going to want to do the same thing here. See how we're not getting any water flow across the sensor surface? We're going to want to tilt the sensor so that the ejection port is facing up a little bit and give it a little bit of a swirl. And as you can hear now, the sensor sounds quite a bit different, and sure enough, we do have good flow across the sensor surface. We're just going to swirl it in here a little bit. Let us get as much of that 7 buffer out of there as we can. And then we're going to do the same thing. We're going to pull it up, get all of that water out of there, and then move it into our 10 buffer. And luckily this one primed right off the bat, but once again you're going to want to confirm with your ejection port that you're seeing water exit that ejection port, like so. And we're going to come over to our display again, and we're going to wait until we see that pH value change and start going up. And same thing as in the 7 buffer. I usually give it about 3 to 5 minutes to stabilize. Really at this point, you can't leave it in here too long. So if you're uncertain or if you need to go do anything else, go ahead and just let it run in this 10 buffer for a few minutes and then come back, and then you can do that 10 buffer calibration. So I know it hasn't updated yet because our conductivity is still 300. The conductivity of 10 buffer usually is at least 9,000 conductivity. There we go. Now we're starting to go up, and we'll start seeing that pH value increase as well. We're going to come over here to our second down arrow screen. We're going to take a look at our pH sensor A to D. I can see that we are at 198.6, which is pretty darn close to what I expect for 10 buffer. 10 buffer is going to be negative 80 millivolts, plus or minus 20 millivolts. So this is our first cycle there. I'm going to give it one more cycle just to confirm that that value is not jumping or moving at all before I initiate a calibration. And again, if you have averaging turned on or averaging a couple of cycles, you'll see this pH A to D change every cycle, but you might notice that your pH value doesn't change quite as quickly because it's averaging to whatever those previous cycles were. In our case, it was about 7 buffer. that won't have an effect on the calibration. The calibration is done entirely off of the pH sensor's raw millivolt reading. So we're at 9.76. We're getting pretty close. So I'm going to go ahead and take a look here. We're still at negative 198.6. So to me, this sensor stabilized pretty quickly. So I'm going to go over, I'm going to hit menu. We're going to go down to calibration. We're going to go to pH, 2-point buffer cal, and we're going to go to buffer 10 and hit select. It's going to tell us to place the sensor in the 10 buffer. However, we're already in there, so we're feeling pretty comfortable with it, and I'm going to go ahead and hit calibrate. You're going to see stabilizing. This could happen for up to a minute before you get a confirmation of calibration. And success. So to confirm that our pH calibration was successful, we're looking for pH to be 10. The next thing we're also going to look at is we can come over here and we can take a look at our pH slope to see if our pH slope has changed from negative 59.2. It might take up to 1 cycle for this slope to update. I'm confident that this 10 buffer calibration was successful because there we are already measuring 10 pH. However, I will give it one more cycle to confirm that that measurement is stable. And we're at pH 9.84. We come over here and there you go. Now our pH slope is updated to negative 56. So I know that I've had a successful pH calibration. We're at negative 197.6. And like I said, this value might go directly to 10 initially, but as soon as we start applying that temperature compensation, we might see a little bit of change. If you're not happy with your calibration, you can always repeat the calibration while the sensor's still running in there. In this case, 9.84 is not quite where I want it to be, so I'm going to go ahead and do that calibration again. And doing repeats of calibrations do not hurt sensor calibration at all. It's actually more likely to be a better calibration the more you repeat it, because the longer the sensor has to stabilize, the more confident we can be in our sensor measurements. So we're reading 10 again. Value hasn't quite updated yet, but we'll do the same thing as before. We'll take a look and make sure that our millivolt value has updated and our slope has updated as well. And those screen blinks are totally normal. Our sensor does a basically fast hard reset every few milliseconds as part of its self-recovery cycle. And that's needed to maintain a certification for ballast water industry. So we're at 9.91. I'm feeling better about that calibration. We're pretty close. We are not at 25C, so I am expecting a little bit of a pH difference here. And we look over here, 55.8, which tells us that our calibration has updated. You'll notice that there is no decimal place there. We ran out of space on that screen, so there is a single decimal place, even if it shows a couple digits. So we can go back to menu and take a look, and we're looking pretty good. Thanks again for watching our technical support videos, and if you have any additional questions, feel free to reach out to tech@halogensys.com. Thanks.